Good evening, everyone. I want to welcome you all to the 17th session of the PSPO webinar series. Today's speaker is Dr. Ji Shukla, who is an assistant professor at the Department of Mechanical Engineering, NIT Patna. His research interests include application of agent-based modeling, AI in manufacturing, operations management, supply chain management, and e-waste management. Presently, his research team at NIT Patna is working on Foxnut supply chain network design, healthcare supply chain with focus on vaccines, and e-waste management issues. He is heading the Entrepreneurship Cell at NIT Patna as professor in charge. He received his doctorate from MNIT Jaipur and master's from BITS Pilani. Today, he will discuss with us his work titled Analysis of Critical Barriers in the Sustainable Supply Chain of MSMEs, a case of Makhana industry. I would now like to request Dr. Shukla to begin with this presentation.
Good evening to all of you. Happy New Year to all of you. And I am highly thankful to Public Systems Lab, IIT Delhi, and Professor S.J. Desmukh and Professor Nomesh Bholia sir for giving me opportunity to present my research work in this symposium. So now I will share my presentation. Is it visible?
Yes, sir, it's visible.
Okay, thank you. So now my research topic is analysis of critical barriers in the sustainable supply chain of MSMEs, a case of Makhana of Foxnut industry. So now this paper has been published in Benchmarking and International Journal, and authors are Abhishek Kashyap and me. My Abhishek Kashyap is my PhD student. Now I will cover this presentation, these topics. Basically, I will first of all, I will discuss about the supply chain and the introduction about the research work. Then what are the various motivations behind this research work? And then I will basically introduce some literature and then research objectives. I will discuss, there are some research objectives, and then methodology section I will cover, and then results and discussion, and then validation part. So in this way, this presentation will flow. So first of all, this is basically the supply chain is considerably a compact structure of planning, design, production, and more importantly, distribution of the product. So basically, basically they hire the farmers, and the farmers produce the makhana using their resources, and then the Makhana or Foxnut will be going in the basically manufacturing plant. Then manufacturing plant itself and the manufacturers basically produce the Makhana, and then after processing the Makhana. So basically, they made the makhana just like sellable. So just like they packed the makhana for the export purposes and other purposes also. And then these foxnuts or makhana basically go for the distributor, and there are various types of distributors, the biggest distributors and local distributors. So big distributor basically distributes the makhana into the local distributors, and then local distributor basically they distribute the product into to the retailers, and the consumers basically they purchase the makhana from the retailer shops. So in this way, this supply chain works. So basically, this is the basic supply chain of makhana industry. So now second term is sustainability involved in this research work. Basically, the sustainability is a kind of development that meets the needs of the present without compromising the needs of future generations. So basically, sustainability involves social, environment, and economic there are three pillars: social, economic, and environment. So on this basis, basically, we have identified our critical barriers on the basis of these three pillars. I will discuss further. This research work basically explores the critical barriers in the sustainable supply chains of Makhana industry located in the northern part of India. So basically, we emphasize we consider the case of Bihar itself, and in Bihar there are some districts like Darbhanga, Saharsa, Purnia, and some other districts in the Bihar. And it also seeks to design a model for the researchers and the managers who want to work in this industry. So at the last, we will basically design a model, ISM model and the fuzzy ISM model. So now come to the motivation part. What are there are various motivations, just like in terms of healthy diet. So Makhana is basically a high value cash crop from wetland ecosystem of India and has the potential to compete with different protein products because it has low glycemic index. So basically, glycemic index basically represents it is a rating system for foods containing carbohydrates. So basically, it also represents like blood glucose level. So Makhana is having low glycemic index, and it has also high fiber content. It is also useful for the health purposes, and low calories, high potassium, and also contains vitamin B1, iodine, iron, phosphorus in addition to calcium. So unlike other dry fruits, Makhana is used as a healthier product, healthy food, as well as snacks also. It is the flavored makhana has the potential to replace the unhygienic food culture of consuming different packed based product. So this is the one of the motivation, and another motivation is in terms of production, employment, and export. If we talk about the production, so on the basis of a National Research Center for Makhana Darbhanga report, it is a minor crop having approximately 16,000 hectare area in India, which yields nearly 24 to 26,000 tons of makhana seed. And another is the makhana sector has created more than 40,000 employment opportunities in northern Bihar, West Bengal, and Assam on the basis of this research work. And every year, Bihar itself produces more than 90% of the country's total makhana. So it is having huge opportunity for the employment. And according to a report, more than 15,000 metric ton of makhana pop is traded annually, as per the Micro, Small and Medium Enterprise Development Institute report. However, at grassroots level, ergonomic producer level, Makhana generates a revenue of less than 250 crore annually. And another thing is this is the Bihar is itself fortunate because Mithila Makhana got GI tag. Geographical Indication Registry under the Central Ministry of Commerce has accepted the petition to rename Bihar Makhana as Mithila Makhana. So it is basically in the last year itself, this December 2021, and it is one of the few GI tagged of India. So and so it becomes opportunity for the vocal for local and for their GI tagged product by making its supply chain more efficient and sustainable in nature. So there is a huge opportunity for the supply chain part. So basically, we reviewed some literature on the basis of three dimensions, just like we reviewed based on sustainable supply chain in MSMEs. Second dimension is we have reviewed some papers based on ISM and fuzzy ISM techniques. ISM means this is basically interpretive structural modeling technique, and fuzzy interpretive structural modeling techniques. So this technique basically describes the interrelationship of the factors. If you are having some factors, so you can basically describe the relationship between those factors among the factors. Okay. So, and another dimension is review based on the makhana industry only. So now quickly we go for the literature review section because it is literature review. This is based on SSA in sustainable supply chain MSMEs. So on the basis of this thing, another is lab based on ISM and fuzzy ISM, And third part is basically LR based on Makhana industries. There is a dearth in the literature dedicated to sustainable supply chain of Makhana industry. Only some of the we have found few literature on the basis of this Makhana industry. So there is a huge opportunity to do something in this area. Now we have formulated three research objectives for this research work. First is to identify the different critical barriers for the sustainable supply chain of Makhana industry. First one. Second thing is to develop a model using ISM and fuzzy ISM method. And third one, that to validate and compare the results using mix-match analysis has been addressed in very limited number of literature. Now the methodology section. In this methodology is basically starts from the detailed review of literature followed by the expert's opinion. You can see here. So this is basically the study based on ISM. So here literature review, it is based on ISM and fuzzy ISM methodologies. There are three ways: study based on sustainable supply chain in MSMEs, study based on Makhana industries, and third one is study based on ISM, fuzzy ISM methodologies. After that, basically on the basis of this literature review, we have identified critical barriers in sustainable Makhana supply chain. Also, we have got basically we have discussed this thing with the experts, industry experts, and based on this Makhana industry, and we have basically consulted with the some researchers and professors. So we have got we conduct some brainstorming sessions among them, and we have identified some critical barriers in this supply chain. Now after that we establish contextual relationship between CBs, these critical barriers. We have basically established this contextual relationship, and after establishing the contextual relationship between the barriers, we have developed a structural self-interaction matrix that is called as SSIM for critical barriers. And then this is now we formulate initial reachability matrix, and then we have developed the final reachability matrix. Now here, if we go in this way, so after establishing this contextual relationship between the critical barriers, we have again developed SSIM with linguistic skill, because here we are implementing fuzzy ISM. Here we are implementing only ISM, interpretive structural modeling. Here we have included fuzzy into this ISM technique. Okay, so there are two things. In this way, if we go in this way, so we are implementing ISM methodology only, and if we go in this way, so here we are implementing fuzzy ISM. So here same process. Here we have to establish the structural self-interaction matrix. And after that, after establishing this ISIM, we have developed initial reachability matrix with linguistic variables, and after that, final reachability matrix. Now, final reachability matrix. After that, we have found basically some crisp value. On the basis of that crisp value, we have made some mix-match analysis. And now here there are two things. Now development of diversified matrix, and then partition of diversified matrix into different levels, and then structural model development for CBs. So in this way, basically this methodologies basically go. This methodologies goes. Now, if you are having some doubts anywhere, you can ask me at any time. Okay. Otherwise, I will discuss some questions at the end of this presentation. But if you are having some problem in between, you can ask at any time. So now come to the identification of critical barriers. Lack of the first barrier we have identified, the lack of proper knowledge. So what is this lack of proper knowledge? So basically the farmers are less informed about the processes involved in this supply chain. So this is a one barrier, lack of proper knowledge. Another is lack of adoption of organic agricultural management techniques. Okay, so this is also one barrier, lack of adoption of organic agricultural management techniques. It is basically defined as the lack of adoption of eco-friendly techniques for management in the sustainable ways of agricultural practices. Now, third barrier is basically buyer-driven supply chain. So in the starting, when I was discussing about the supply chain. At that time, I told you that the supplier hired the farmers. So basically, and supplier itself manufacturer. In the case of Makhana supply chain, so they basically this is totally driven by the buyer. Buyer wants this thing. So this is that's why this is also one of the critical barrier. Now, the lack of modern techniques involvement. Here, the lack of modern techniques involvement, and because the farmers basically use traditional way to pop the makhana, and multiple intermediaries. There are any industry is not excluded from the problem of multiple intermediaries, but there are huge number of agents in this supply chain, and absence of organized marketing structure. This is also one of the critical barrier. Another is weak socio-economic condition. And another is improper handling of product prior and post harvest. This is also a big problem. And improper packaging. And another is inefficient transport facilities. Okay, so these are the basically there are 10 barriers we have identified. And now we have to establish the interrelationship among these barriers, so that any manager or any manufacturer can understand what are the problems, and if they understand this thing, so they can improve the supply chain. Now here we have categorized our barriers into these three pillars: social, economic, and environment. So this lack of proper knowledge comes under social. Buyer-driven supply chain, this is comes under social part, and this multiple intermediaries we can include this thing in under social. Economic, weak socio-economic conditions, lack of adoption of organic agricultural management techniques, and absence of organized marketing structure. And another environment related barriers is like inefficient transport facilities, lack of modern techniques involvement. Another is improper handling of product prior and post harvest, and improper packaging. Because if we do improper packaging, so it will basically harm the environment. Now, now come to the model formulation. So this is the major part of this research work. How to form the model. So basically, we have basically considered this technique, interpretive structural modeling technique, and this starts with the establishment of the conceptual relationship among the CBs with the help of discussion with the industry person and academia. And the development of contextual relationship leads to the development of structural self-interaction matrix, SSIM. And the next step is the formation of the reachability matrix along with the addition of transitivity. So basically now, and another method is fuzzy ISM we have used here. So this is a fuzzy ISM. The input given to the relationship between the constraint is not a binary. Instead, it is number between 0 to 1, depending upon the extent of relation present between the constraints. Okay, so here we have used some linguistic terms. So now this is you can see this thing. Now you can better understand about this thing. It's like this is an ISM model. This is still symbols for the ISM. In ISM, to interpret the relationship among the critical barriers, 4 different symbols. There are 4 different symbols: V, X, A, O. These 4 symbols are used for the establishing the contextual relationship among the barriers. It's like if we put V somewhere in matrix, so it means that factor I will help to achieve J. If we put X in the matrix, it means that both I and J help to achieve each other. Okay, it will help to achieve each other. Now, if we put A in a matrix cell, so it means that factor J helps to achieve I. This is the vice versa of this V. Okay, and if we put VO, so basically this is basically A is reverse of this V, and O means both factors are unrelated in the case of ISM. But in the case of fuzzy ISM, we consider triangular fuzzy numbers basically. So here linguistic terms, no influence. If there is a no influence between the factors, between the barriers, or so we will use 0.00, 0.0, 0.0, and 0.25. This is triangular fuzzy network. So this is the fuzzy number. So we will use three numbers, 0.000 and 0.25. If very low influence is there, so 0, 0.25 and then 0.5. And low influence is there, 0.25, 0.5 and 0.75 we will take. And if high influence is there, so we'll take 0.5, 0.75 and 1. And very high influence is there, so we will take this value, 0.75, 1 and 1. So in this way, we will move. So now come to the okay. So structural self-interaction matrix. This relationship is established by an extensive discussion with a team comprised of experts from Makhana industry, professors, research scholars working in this domain. So here these are the 10 barriers. This is CB1 and this is CB1 also. So what is the so this is this CB1, this like here we basically put V here. So V basically depicts this I will influence to achieve this J barrier. It means that CB1 will help to achieve CB10. CB1 will help to achieve CB9. Okay. And if X is there, so it means that this CB1 and CB7, critical barriers 1 and critical barrier 7, will achieve each other, will help to achieve each other. Okay. And O is there, no interrelationship is there. And if A is there, it means that CB7 will help to achieve CB2, J2I. So are you getting? So in this way, we can understand this relationship, structural self-interaction matrix, how you can build this structural self-interaction matrix through these four symbols. Now, in the case of now after that, this basically we are implementing this ISM method. So here, this is SSIM we have established. After establishing this SSIM, contextual relationship among the barriers, we have established this reachability matrix. Reachability matrix means that the conversion of SSIM into binary matrix is the key for the formation of reachability matrix. This conversion is done by replacing the symbols V, A, X, and O as per the rule discussed here. It's like if in SSIM, IJ entry is V. If V is there, so then IJ entry in RM reachability matrix takes 1 and JI takes 0. Just like here. In the case of just like V, CB1, CB10. Okay. So CB1 to CB10. Here, this is V. V is there. So V is there means if V is there, so we will put 1 here. So we'll put 1 here. So in this way, you can build this reachability matrix, because just like if X is there, just like here, CB1 to CB7, X is there. So if X is, then IJ entry in RM takes 1 and JI also takes 1. So just like CB1 to CB7. So CB1 to CB7 is like 1. And CB, so here this is 1. And if O is there, it's like CB2 to CB3. It means that this is CB2 to CB3. CB2 to CB3, this is 0. So there is no relationship. Okay. O is there. So it means that RM, IJ entry in RM will take 0 value and J also will take 0 value. So using this basically rule, you can build this reachability matrix. After developing this reachability matrix, we have to establish final reachability matrix after including the transitivity. So transitivity, basically, this is an underlying hypothesis in ISM that defines if a factor X affects Y and Y affects Z, then X will affect J. So in this way, you can basically define transitivity. Just like here, 1 star. It means that CB2 to CB3, X to Y, X affect Y. And now CB CB2 to CB3. So CB3, this is X and this is Y. Y affects Z. So this like CB3 here, CB3 you can see here, CB2 to CB3 here 0 here. So we will basically see if other factors also influence some factors. It's like initially we have put 0 here, but somewhere it affects some other factors. That's like in some quantity. Okay, so that's why transitivity comes into the picture. Okay, it's like here CB2 to CB3 and just like CB3 to affect CB6. Okay, CB3 to CB6 and CB6 to CB2. So in this way, we can put here, it's like CB2 to CB3 and CB3 to CB6, CB3 to CB6, this is one. So in this way, you can build the relationship between CB2 to CB6. So you can put it here 1 star. So in this way, you can make this final reachability matrix after including transitivity hypothesis. Okay. So now here we have established driving power also and dependence power. It's like this is CB1 is having 5 dependence power. This is CB2 is having 6 dependence power. In this way, we have established some dependence power and this driving power, because it is useful when we will make micmac analysis. When we'll do micmac analysis, then these dependence power and driving power will use. Okay, so now next, now fuzzy implementation. Here SSIM with linguistic scale. So in the case of fuzzy ISM, only difference is that fuzzy ISM deals with the linguistic scale of the fuzzy numbers. Okay, in the case of only ISM, we were using VXAO. In the case of fuzzy ISM, we will use just like here, very high, very low, high, low, and just like O. So in this way, you can build this contextual relationship or SSIM matrix. Okay, and now after establishing this SSIM establishing after formation of this matrix, we will again this initial reachability matrix with fuzzy linguistic variables, IRM with fuzzy linguistic variables formed as on table, this thing by providing the specific linguistic values to the entire elements depending upon the extent of their interrelationship. So in this way, you can see here, this is CB1 to CB2, this is VH very high. So in this way, you can put all these things into the matrix. Now, this is the final reachability matrix with triangular fuzzy numbers. Okay, triangular fuzzy numbers, the inclusion of fuzzy numbers into the IRM. So here, just like there is no relationship, or this is because CB1 to CB1, it will be 1, 1, 1, and here CB1 to CB2, this is very high. So very high, it means that we have taken this value from that initial table. So this is 0.75, very high means 0.75, 1 value. CB3, because it is very low value, so very low influence. So here we have taken 0, 0.25, 0.5. So in this way, we can build this final reachability matrix for this fuzzy ISM. Okay. So now we have come to the calculation part. Calculation of the crisp value. These are some equations we will use for establishing calculating this crisp value. Now come to this driving power with crisp value. So here we have established this crisp value after defining this driving power. Driving power means this is Lij, Mij, Rij. So in this way, we can define this. This is Lij 3.5. This is 5.5. After using this part, after using this thing. Okay, just like here 1 plus if we are it's like here just like dependence, this is driving. So 1 plus 0.75 points plus 0 plus 0.5 plus 0.25 plus 0.25 plus 0.25 plus 0 and 0. So if we add these things, so we will have this value. Okay, so in this way we can establish this values. And again, dependence. And if we are looking for dependence power, so this is one. So dependence power, so we can calculate this like here: 1 plus 0 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 plus 0. So in this way, okay, column wise. If we are looking for just like here, if we are looking for this driving power, so we will go for in the row. And if we are calculating this dependence power, so we will go column wise. Okay. So we will go column wise. So in this way, you can calculate this thing. And after calculating this dependence power and driving power, we can calculate this crisp value on the basis of given these equations. And this is also discussed in the paper. And now come to the level partition. This is very important part of this research, because after establishing this level, we can basically get the idea about the most influential barrier. Okay, which barrier we have to consider, and industry can consider that barrier. So this is the reachability set. And how this reachability set, basically we have to see the this table, initial table, basically this table we have established. So okay, this table. Okay, so we have to see this table after establishing this thing. So in this way, you can just like here. So 1 1 1 1 2 3 4 5 6 7 8 9 10, and here, and see the column wise antecedent set 1 4 5 6 7. Okay, 1 4 5 6 7 for the antecedent set. So you can see here this thing. Sorry. This is 1 4 5 6 7. This is antecedent set, and this is 1 2 3 4 5 6 7 8 9 10. This is reachability set. So if we see reachability set, so we have to see the row wise, and if we want to calculate this antecedent set, so we have to look for the column wise. Okay, after that we have to get this intersection set. This is intersection set, and then we will establish the labels. So this is like first label. So first of all, we have to establish the label first, and then after establishing the label 1, then again we will build another table. Then only we can find all labels. Okay, because in this table itself we have basically we are showing you all labels in one table, but the process is you have to present each table for each label. Then only you can after at the end of the solution, you can get the whole label. Okay, so we are not showing here all tables. We are basically I'm showing you only the complete last table where you can see all labels. Okay, so now this is this identified labels helps in the formation of directed graph, and consequently final ISM model is formed. Now this basically the results and discussion and part. In the first level of hierarchy, you can see this buyer driven supply chain. Now first level of hierarchy means this is this is the level. This is hierarchical model of CBs. You can see here, this is the first level. This is the first level where you can see improper handling of product prior and post harvest. This is buyer driven supply chain, and this is absence of organized marketing structure. CB8, CB3, and CB6. These three are at the first level. Another second level, this is the inefficient transport facilities, and third level at this is improper packaging. Fourth level, this is lack of adoption of organic agricultural management techniques, and these are the four barriers. And at level 5, this is lack of proper knowledge. So this CB1, lack of proper knowledge, is the basically most influential barrier. If we tackle this barrier, so we can basically overcome other barriers also. Okay, so most influential barrier, this is CB1, and it is also independent barrier. This is also independent barrier. This doesn't depend on any other. Basically, it influence other barriers. Okay, so this is basically, and this we have got this hierarchical model after establishing the labels. Okay, and these results and discussion, these are the things we have described. So now, and now validation part. Validation part, it means here we have used this MICMAC analysis, and it is based on principle of multiplication properties of matrices, which is used for the analysis of driving power and dependence power of different factors. And here there are four elements in MICMAC analysis. First one is autonomous elements. These elements are basically having weak driving as well as dependence power, and are generally disconnected from the system. Okay, and dependent element basically it contains the barriers having weak driving power but strong dependence. Dependent elements means it contains the barriers having a weak driving power but strong dependence power. Okay, and they are represented in the second quadrant. Linkage elements, these barriers have strong driving power along with strong dependence power, and they are present in the third quadrant. And the independent elements, these are the having strong driving but weak dependence power. So this is plotted in the fourth. So here you can see this is MICMAC analysis. So in this MICMAC analysis, you can see these are the autonomous region. This is autonomous region, and this is dependent region, and this is linkage region, and this is independent region. So in this independent region, and this is autonomous region, and this is dependent. So in the, you can see here CB1 lack of proper knowledge lies in the independent region. Okay, it is having strong driving power. Okay, it is having strong driving power but weak dependence power. Okay, so it influence other barriers. And in the autonomous region, basically, so weak driving and weak dependence. And in independent region, basically the dependence power is high. So, and this linkage region is strong dependence and in strong strong driving power. But you can see here fuzzy MICMAC analysis, you can find most of the barriers are common, but you can see here it's like CB9. CB9 is basically lying in the autonomous region, but in the case of MICMAC analysis only, you cannot find CB1 here, CB9 here, because if we are including fuzzy into this picture, into the any technique, so basically you are basically examining the technique or examining the problem minutely. Okay, so here we are using triangular fuzzy numbers. So we are basically examining minutely the problem. So basically, so CB9 becomes autonomous region, and it is having basically this is autonomous. This is basically weak driving as well as weak dependence power. Okay, so in the case of and in other CB3, CB8, CB3, CB8 also lies in the dependent region, and CB10, you can see here, CB10 lies in the linkage region where strong dependence and strong driving in the case of MICMAC. But here, in the case of fuzzy ISM, you can see CB10 lies in the dependent region because it lies in the MICMAC, lies in the borderline. So it becomes in the dependent region. So it is basically, it is having weak driving power. Okay, a strong dependent power. So in this way, you can see. It's like in the case of here, linkage region CB2, CB4, CB2, CB4, CB5, and CB7 are there, but CB6 in the case of MICMAC, but CB6 is not there in the case of fuzzy MICMAC. Okay, so and you can find this CB6 in the case of this dependent region. So in this way, you can validate our model and see this thing. CB1, basically, this is only one factor, only one barrier, which is basically independent, which does not depend upon any other factor. And it also depicts from the this level also. You can see here, lack of proper knowledge is basically is influencing other factors, other barriers. Okay, so if we can overcome this lack of proper knowledge, so we can overcome any other factors, any other barriers. So this is the finding of our this research paper, and we have basically established the relationship among other factors also, other barriers also, and some just like here the factors present at the bottom hierarchy are the most important as they affect all other factors present at the upper level of the hierarchy. So the reason that manager need to remove or improve these factors first. Okay, so in this way we can discuss this part. So now we have we have basically consulted our problem with these companies also. We have basically taken the help from these companies: Farm Yoga Organic Private Limited and Kushwaha Farm to Factory Private Limited, Delseed International LLP. So we have contacted these industries, and they have helped me a lot regarding the Makhana issues, Makhana supply chain issues. Okay, thank you so much.
I request everyone to raise your hands in case of any queries. We'll take them up one by one. Prashant, please go ahead.
And basically, this is MCDM based problems. We have basically used MCDM techniques, multi-criteria decision making techniques. So this is one technique, ISM.
Hello, sir.
Yes.
Sir, my question is in level partitioning, you have assigned barriers 3, 6, and 8 at level 1. But you have 3 sets of barriers for level 1, like 3, 4, 5, 6, 7, all barriers, and 6, 8, 10. So my question is how you have selected 3, 6, and 8 from the sets for level 1.
So basically, these 3, 6, 8. So we have got this table. On the basis of this table, we have established this hierarchy model. It's like here, this is the first 6, 8, 10 intersection set. So this is 6, 8, 10. Okay. In the fifth, this is second level. In the second, just like here, the first in the first level. So this is the first level. So six barrier, sixth barrier. This is eighth barrier, and this is and third barrier. Sorry, this CB3, CB6, and CB8. This is first. Okay.
Okay, got it.
And fifth one only CB1. Only CB1. And there are different tables. Before making this table, this is basically final table. Before reaching this table, we have to make another other tables also. First of all, we will formulate level first, then we will cut level 1, or we will cut CB that factor itself. And after that, we will cut this table and then make another table. Okay, after this cutting this barrier, then finally we will reach this fifth level. And then we have to basically some page constraints or whatever the things we have to formulate. We have to show only one table there. We have to basically formulate all the levels at one table. But this is not the process. We have to go from level 1 to 5.
Okay, got it. Thank you.
Rajat, please go ahead.
Hello. Good evening,
any
sir.
problem? Okay.
Good evening, sir.
Good evening.
Sir, I wanted to ask that the barrier identified totally based on the literature, or there is some kind of like expert opinion in while selecting the barriers?
Expert opinion. We have taken expert's opinion also. We have basically discussed this thing because we have contacted to these companies. So we have contacted to senior managers of these companies, and they have basically given some inputs. And we have contacted to some researchers also. We have contacted to some professors, academic scholars also. And on the basis of those expert opinions, we have formulated this identified barriers.
So, in continuation of the previous question, is that the identified barrier, is there anything like you have identified more barrier and then after expert opinion, you just found out that some are the relevant, some are the irrelevant, and based on
Yes,
that,
yes.
you have selected that.
Yes. We have initially basically we have identified more than 20 barriers, and after basically some factor analysis and some analysis, we have basically identified, we have come to this 10 barriers. After conducting some brainstorming sessions, and we have consulted with the experts, we have taken some experts' opinion from the Makhana supply chain only.
Okay.
Initially, we have basically reviewed literature from the food supply chain. So there are many barriers.
Okay, sir. Okay, thank you, sir.
Okay. And this is one of the basically important technique, MCDM technique, where you can implement anywhere. If you are having problem, and if decision making is involved in your problem, you can implement this type of technique, just like fuzzy ISM, fuzzy demetal technique. So these are the some techniques.
So how it is different from AHP, and why we cannot use AHP other than
AHP,
ISM?
basically AHP is starting just like basic level algorithm. Okay, and if you include fuzzy into that, so it will be more beneficial for the problem.
Okay, thank you, sir.
And it is having basically uncertainty also. It handles uncertainty.
Okay, sir. Thank you.
Is there any other query from anyone else?
Hello. Sir, I wanted to know the transitivity where you added and the reachability matrix, I think. And
Yes.
so I just once again, can you repeat what was the purpose for that of it?
Basically, the transitivity comes into the picture. Why? Because we have initially we have got this reachability matrix. Okay, initial reachability matrix. So initial reachability matrix, some zeros are there. It means that there is no relationship between CB2 to CB3. See this table. So this is not, there is no relationship between CB2, CB3. So basically we are ignoring this relationship. But if we include transitivity, it means that X affects Y and Y affects Z. So in this way, you can basically include some influence also. So that's why we are including this transitivity here. Okay, it means that CB2, just like critical barriers 2, will affect CB3. How much affect? We can elaborate this thing using fuzzy. Okay, you can use fuzzy, but only of the influence is there, so we can use transitivity in the simple ISM.
And sir, the structural self interaction matrix ASSIM, is it similar to activity relationship diagram?
In which
activity relation diagram, it is also in I found it like a bit of similar. So just ask.
maybe I don't know activity relation diagram, but this is the, so basically it defines the contextual relationship. Okay, interrelationship between the factors.
Inter and relative also.
Relative also.
Relative. Okay.
Megha, please go ahead.
Sir, you have used that 1 to 10 scale for fuzzy ISM, no? ISM.
Yes. Point.
That next slide.
This is.
No, next one. Yeah, this one. The previous one.
These are the equations.
No, the previous slide.
This is the previous slide.
In fuzzy next ISM, one.
In fuzzy.
There were like 1 to 9 ratings. Yeah. Next one. This one.
This one. Okay. This is the label.
Yeah. So like it is restricted, like we can use 1 to 10 table, or we can take any other scale.
Basically, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are the numbers of barriers. If you are having 15 barriers, so it will show you the 1, 2, 3, 1 to 15. Okay, this
Okay.
is showing the number of factors itself.
Okay. So these are the factors.
These are the factors. And why? Because this is reachability set. Please understand this thing from here itself. It's like here. This is a reachability matrix. One, because here is one, 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 one. It is all. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All these barriers are having this one value. That's why here this is reachability and driving power is 10. And where is antecedent set? Antecedent sets shows this thing. This is 1. This is CB1 because here 0, 0 and this 1 star. So this is CB4. So 1, 4, 5, 6, 7. These it will be the antecedent set. So see this thing 1, 4, 5, 6, 7. Now see this table 1, 4. This is 1, 4, 5, 6, 7. Antecedent set and this is 1 to 10. Now intersection set will be, because here 1, 4, 5, 6, 7. So intersection set will be 1, 4, 5, 6, 7.
Okay.
Okay. And this is basically, this is showing the 5th level. First of all, we will see for the first level. Okay. So another time we can discuss this thing. And or you can see one of my paper published in gray systems, sorry, in some paper in Emerald. So you can see that paper also. Where in that paper I have basically described this thing. I have discussed this thing.
Okay.
Hmm.
Thank you.
Is there any other query? Okay, so in case of no further queries, we can end this session now. Thank you, Dr. Shukla, for such a detailed and informative presentation.
Thank you so much. Thank you so much.
Request the team members to please stay back.
Okay. Just wait.
Okay, so I hope everyone apart from the team members have left the meeting.
Excuse me, is the session over now?
Yes, the session is over.
Okay, thank you.
Okay, sir is having a doctor's visit, so we will not have the agent today. Also, he has said that almost all of us have copied the vision and cause from the site. So he's saying that we can revise it, given that he has already recognized that we've copied. And I will circulate the form again, and we can fill it before the next AGM. Okay. Thank you, everyone.